So 6.2, we're really going to start getting into some new stuff, things with polynomials. What we did in 6.1, all of that should be stuff that you've seen and used before, even if you required a refresher on it. So today we're going to just kind of get started talking about the graphs of different polynomials. In Unit 5, we specifically focused on quadratics, but in Unit 6, we are going to talk a little bit about quadratics, but we're also going to talk about the other polynomials too. So the first thing we have are parent functions, and what that means is that's just the general basic function with nothing added or subtracted to it. When you add and subtract things, it changes the location. Sometimes it can flip them, and it makes the polynomials have more humps than just the parent function. So we're going to go through those. And so the first one we talked about was a constant. These are all dependent on the degree. So if a degree is 0, we talked at the very beginning, that was a constant. So it's y equals, and it's some number, and I'm just going to put c. C just represents some number. And so depending on whatever that number is, let's say that number is 3, my graph is just going to be a horizontal line that goes through whatever that number is. That one's just pretty, we don't do much with those really. If the degree is 1, so y equals x, that's a linear graph that forms a straight line, and the parent function, just plain old y equals x, not 5x minus 2, just y equals x, looks like this. Then we get into quadratics. Y equals x squared is the parent function, and it looks like this. Now I'm also going to show you another way that you might see a quadratic. It might look something like this. So the parent function I did in green, but another choice that's still a quadratic, that's what I did in orange. Cubic is y equals x cubed. So the parent function looks like this. So that's just the very basic, general, original cubed function. But you'll usually see them more like this. The curves are a little bit more dramatic usually. Quartic is y equals x to the 4th. Now if I actually look at these x squared and x to the 4th, if I actually look at those graphs, hold on. They actually look about the same. The parent function for a quartic is very, very similar. It's actually more flat at the bottom. But that's not usually how you'll see a quartic. Usually, Oh, hold on. Usually they'll be more like this. And then a quintic, y equals x to the fifth. The original parent function does look a lot like x cubed. Okay. However, that's not how you'll normally see them. Now, the reason I knew kind of how to draw those, when you have an x squared, it can have up to 2 x-intercepts. We'll talk a little bit more about how many x-intercepts it could have, but it could have up to 2. A cubic could have up to 1, 2, 3. Quartic could have up to 1, 2, 3, 4. And a quintic could have up to 1, 2, 3, 4, 5. So just like with quadratics, we're going to spend a lot of time finding those x-intercepts later on, not right now. Right now, we're going to focus on some of the basic features of the graphs. And the first one is the end behavior. I'm talking about which direction the arrow's pointing. So the direction the arrows are pointing. And I can tell this by looking at 2 things. Number 1, the way I can tell is if looking at the degree, I want to know if the degree is an even or an odd number. Okay. So is it 2, 4, 6, 8 or is it 1, 3, 5, 7, 9? And then also I look at the leading coefficient. That's the number in the front. Is that number positive or is it negative? Is it 1, 2, 3, 4, 5, 6, 7? Or is it negative 1, negative 2, negative 3, negative 4, and so on? If we have an even degree and a positive leading coefficient, both arrows point up. That's just like these examples right here. Those had an x squared and x to the 4th. That's an even degree, and I didn't have a negative in the front, and those arrows pointed up. If it's an even degree, but I have a negative number in the front, they both point down. If we have an odd degree and a positive leading coefficient, that's like these. The left side points down, the right side points up. And then odd degree, negative leading coefficient is up and then down. We're going to do some examples, and I actually am going to re-sketch this chart so we don't have to flip back and forth. So we have an even degree, odd degree, positive leading coefficient, negative leading coefficient. So up, up, down, down. Now you're not going to get to use your notes on this test. So let's say you forget this. What's a tool that you have that allows you to look at graphs?
Calculator.
Your calculator. You could just type these in and look at the graph to see if the arrows would point up or down. But when we do our practice, that's not how we're going to do it. So let's look at number 1. What is my degree? What's my degree? What's the largest exponent? The degree itself is 4. It is a quartic. The degree is 4. Is that even or odd? Even. What's my leading coefficient? 4. Is that positive or negative? Do what? Positive. So positive, even, they both point up. Now here's how we write it. We use the words rises or falls. Rises if it points up, falls if it points down. So we would say that this one rises to the left, rises to the right. Number 2. What's the degree? 2. That's even. And my leading coefficient? Negative 1. So even, negative, they both point down. So I would say falls to the left, falls to the right. Number 3, what is my degree? 3. What's my leading coefficient? 2. So I have an odd degree and a positive leading coefficient. So it falls to the left, rises to the right. Any questions? Number 4, what's the degree? It's 3. And my leading coefficient? Negative 1. So odd and negative would be rises to the left, falls to the right. I want you to do 5 and 6 by yourself. Number 5, you should have had falls, falls, and 6, falls, rises. Any questions? Now the last 2, you're looking at the graph, and we need to describe the degree. So telling if it's even or odd, and the leading coefficient. Is it positive or negative? So tell me about the arrows. How are they pointing?
Down.
They're both pointing down. So if I look at my chart, to both be pointing down, what's true about the degree? Even. And the leading coefficient?
Negative.
And I just realized I put an in there. I guess I had negative in my brain. So it's even degree and a negative leading coefficient. So number 8, tell me about the degree. Odd. And the leading coefficient? Positive. Good. All right. The next thing that we're going to talk about with the graphs are what are called turning points. You have to be able to find these. You do it in the calculator. It's not hard. But you have to, like, a lot of the rest of the unit depends on these turning points. So a turning point is where the polynomial changes direction. So let's say that this is my polynomial. I have 2 points where I change. Here I'm going up, 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 down, 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 up, 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 up. So those at the tip top of the hills and down in the valleys, those are your turning points. And they're either called maximums or minimums. So actually, you don't have to change on yours, but I'm gonna make mine a quartic. So in advanced topics, maybe you will talk about something called an absolute maximum. That means we're talking about the highest point overall, which in my graph would be up here. That's the highest of all of the hilltops. That's the absolute maximum. But what we're going to be talking about is what's called the relative maximum. So we're talking about all of the points that are on the hilltops, not just the highest hill, all of the hills. Those are called relative maximums. And so like at this point, this is the highest point of any point right around it. This is the highest point of any of the ones right around it. Those are relative maximums. The ones down below are the relative minimums. So you could have more than one minimum. Those are what's in the valleys. You could have more than one maximum. If it's a quadratic, you either only have one maximum or one minimum. So you may not have both. And we're going to use that a lot in the next little bit. So I'm going to show you how we can do this on the calculator. There's no calculations that you have to do. You just got to do it on the calculator. So go to y equals and type in x cubed minus 6x squared plus 7x plus 2, and then go to the graph. And then you're going to hit the trace button, and that puts your cursor on the graph. Okay. And you're going to use your arrows until you get to where you think the maximum is. Now I want you to kind of scroll around back and forth. If it's the maximum, the y value would be at the highest. So like here I've got 4.26. If I go right, I've got 4.29, that's higher, and then I go back down, 4.15. Now this is not going to get the perfect absolute maximum. Not absolute. This is not going to be super precise because we're just using the trace button. There's some other steps that you could get the exact perfect point, but we're not going to do it that way. So you're just going to be really, really close. So my maximum is 0.75, 4.29. And then if I scroll, now I want the minimum. I want the lowest. And this, if I'm looking at the y value, this is my lowest point. Okay. So it's 3.33 negative 4. If I'm doing 2 decimal places, that would go up to 3 zeros. So I'm just going to put 296. 2 to 3 decimal places is where I want you to be. And that's it. But you've got to get good. You've got to be quick at getting these. You've got to know those calculator steps. So we've got time to do these last 4. They shouldn't take very long. We're going to find the max and the mins. Actually, these first 3 rows, you all do numbers 9 and 10. Those 2 rows over there, you all do 11 and 12. So see if you can find those max and mins. So I was able to get 9 and 10 done. Those of you that did these 2, check to see if you got what I got. Now somebody that did 11 and 12, or did 11, what'd you get for your max?
1.97, and then my y is
3.99. Okay. And what'd you get for your minimum?
I got 0, 0.
Okay. 12. We should have 1 max, right? No. 2 maxes. No. 1. Okay, what'd you get for your max? 0, 4. And minimum?
Negative 1.27 and negative 1.35.
Negative 1 point what?
25.
Okay, and then the other one? Anybody get it yet? Okay. We'll just leave that one blank.